of load and design associated distresses, in which we discussed different types of stresses which that acts on different members of infrastructure, and then we talked further about how these different members respond to loads, starting with the simply supported member. Okay, so we first saw simply supported member. uh, then we talked about cantilever member, then continuous member, then beam column joint, and then columns. For each of them, we saw how stresses are generated, how distresses happens, and how to prevent distress. Additionally, we also talked about pre-stressed members and how distresses occur in that also. After this, we discussed how distresses can be identified in concrete structures, where we briefly discussed 13 categories, which were crazing, spalling, disintegration, scaling, dusting, pop out, honeycombing, buckling, delamination, seepage, and erosion. And then we went a little deep with the discussion on cracking, in which are major and occurs mainly. So, in cracking, we discussed two types: structural cracking and non structural cracking. Structural crackings are those which are major and they mainly occur due to faulty design or subsoil failures. Like here, you can see major cracking, and these are some of the examples of structural cracking occurring in a building. Along with this, we also talked about non-structural cracking, which are mostly minor, and these are few examples that we saw, which can be the reasons for non-structural cracking. Okay. We also brushed up some the definitions of active, dormant, isolated, and pattern cracking. In addition to this, and once we know distresses, we talked about how distresses can be evaluated in existing infrastructure. In this, we first discussed about visual inspection. Then we talked about semi-destructive testing, in which we saw different testing like pull out and pull off, core sampling, penetration resistance, and carbonation depth measurement. And then we talked about non-destructive testing, in which we saw rebound hammer, UPV, half cell, cover meter measurement, and resistivity measurement. So this was all from the last session. Now, we left one part of evaluation method last time, that is petrographic analysis of concrete. So, by this, we aim to examine the mineralogical and chemical characteristics of a concrete sample using microscopes. So, from field, when we are doing semi destructive testing, we can also collect some small concrete samples and test them for further like micro level understanding, and that is known as spectrographic analysis. So the principle is to collect samples from lump or cores, and then impregnate, and these samples are then impregnated by resins to act as a micro representation of the structure, and these help us to identify the basic components, crack and deterioration products of concrete, as well as to verify its quality. Okay, so in the images, one can see different types of results being accomplished from spectrographic analysis using high power microscopy and diffraction instrument. So you can see some small concrete sample being collected and analyzed using high power microscope. How we can visualize those samples at a much smaller level, and further on how we can study the structure or the composition of those sample also. For simplicity of discussion and understanding, I have broadly divided petrographic analysis into two application categories. The first one is identification of ingredient used in concreting. Okay. In this includes identifying which aggregate has been used, which cement has been used, if there is some SCMs that has been used, and most importantly, the suitability of these components for use. Okay, so in this slide, you can see three different equipments and their associated testings. So first of all, you can see this inductively coupled plasma atomic emission spectroscopy, which is also known as ICP-AES. So this instrument is used to identify which cement was used and is the cement suitable or not. So basically, we can take some small cement powder and we can analyze its chemical composition. Now, based on composition, we can check whether the cement passes the particular criteria set by the standard provisions like IS codes. If they have set certain criteria that this should be the range in which certain minerals should be present in a cement for its suitability of use. So based on our the results that we collect from ICPAES, we can check whether a cement is passing that criteria or not, or whether it is suitable or not for use. Similarly, we can check this for SCMs also, and we can check how much silica, alumina, iron it is present, and how it may behave later on when it will react. Okay. Second is XRD, X-ray diffraction. So this is used to identify which type of aggregate is used and is it amorphous. Okay, because we know if aggregate is amorphous, then it can lead to aggregate silica reaction or aggregate carbonate reaction. So using XRD, we can examine that, and in addition to that, we can examine the cement also, whether it is crystalline or it is amorphous, and how much reactive the cement is. So this is a general representation of XRD, how we see. So we obtain different peaks at different angles, and then matching those peaks based on the data set, we can identify what are the phases present in the sample. Okay. Finally, we can also use thermogravimetric analysis, also known as TGA, and using this, we can check upon how my sample is behaving when it is exposed to high temperature ranges, which will help me to detect how much carbonation has occurred based on how much calcium carbonate was formed in that. We can also detect how much hydration occurred based on how much water loss it gave me from the start to the end, and we can also check the reactivity of SCM based on how much calcium hydroxide it consumed during hydration. Okay, so these are very deep applications of petrographic analysis. The second is determination of air voids, cracking, and investigation of chemical attacks. So these are basically carried out through different forms of microscopy based on the need of light source and magnification power. These microscopy include stereo microscopy, polarizing microscopy, fluorescent microscopy, metallurgical microscopy, and electron microscopy. Okay, in the first three images, like this, and this, uh, we can see different forms of microscopy being used. One for detecting voids and segregating different components of a sample connected from a concrete bridge. So here you can see we collected a sample from a concrete bridge, and we are detecting different voids and segregation that occurred. Okay. And the fluorescent one shows how thin film concrete sample appears under microscopy, and which can give us information related to interfacial transition zone and aggregate cement distribution. While here also you can see voids and different phases was discovered from the sample collected from one field. Okay. While in the grayscale images, the top one shows alkali aggregate reaction, which resulted in gel formation. So you can see here gel formation was occurred, due to which cracking occurred, and we can visualize it easily through microscopy, which won't have been visible to us from naked eye, and which would have caused it difficult to estimate what is the reason for failure in our structure. Okay. The gel formation you can see led to cracking near ITZ, which would not be visible by naked eye, and it is clearly visible in the microscopy. And the last bottom image also you can see cracking in and near aggregate, which again can be due to either sulfate attack also if there is some attringite formation, or maybe due to alkali carbonate reaction also. So in this way you can narrow down the possibility of what may be the reason of distress when you go to petrographic analysis. I hope everyone are clear with petrographic analysis. We just brushed up this topic since it is quite deep and takes a complete course of 12 weeks for thorough understanding. But for now, with whatever little you know, and the two major categories I explained and different types of instrument I explained to you, it is enough for the basic understanding of these things. After this, there is one more important and often practiced on site testing, which is known as load testing of concrete structure. So, the aim of this testing is to non destructively evaluate the structure response or to loading. Now, when it is done, so it is done when we need to check the integrity of the structure, when the integrity of structure is questioned. And secondly, when the structure is to be used for a newer function with higher loading, then we need to conduct a load test to check whether the structure is safe or not. Third, when the structure needs to be evaluated for extreme loads, so suppose we have designed the structure and we need to check whether the structure can take extreme loads or not. Then we conduct load testing. And fourth, when the structures need to be evaluated after repair or retrofitting. So suppose when structure has undergone repair and retrofitting, and now we want to estimate how good the repair was, or is my structure strengthened enough to take the load again, so I can do the load testing. Okay, so in this, the first step is to decide the test load magnitude, which is decided by taking dead load, live load, and other additional loads like snow load and rain load into account by different combinations of loading factors. So you can find much detail about these loading factors, how are they taken in this code ACI 437.2 part 30. So you can see different combinations of load can be considered based on different criteria. Now, once we have decided the test load, the load for which we will conduct the load testing, we can apply this load in two manner, either monotonically or in a cyclic manner. In monotonic load testing, what we do, we initially apply a small portion of the load, say 20%. We hold it for some time, then we increase the load till again 40 to 50%. Then we hold, then we increase the load to 60 to 80%, and then we increase the load till 100% of this uh, test load magnitude. When we have increased the load till 100%, we let the structure under load for 24 hours, and we measure the response of the structure, the deflection in the structure, and then we unload the structure. And again, after unloading, we wait for 24 hours and again check the deflection of the structure. Okay, so once after each loading step, we check the deflection. After complete loading, we keep it for 24 hours and check the deflection, and then after unloading and 24 hours, we check the deflection. This is monotonic load testing. And in cyclic load testing, what we do, we increase the load in a cyclic manner up till a certain percent, and then we reduce the load, we check the deflection, again we apply load and decrease the load and check the deflection. Then we apply a load for much higher value compared to the total load, like 80% of the total load, and we apply these load in a cyclic manner. And finally we apply the ultimate load, the TLM, and in a cyclic manner and check the deflections. After each cycle we check the deflection, and we note the deflection, and then finally we will unload it and check the deflection. Okay, so based on the deflection, criteria are defined. Okay, so what will be my residual deflection and what will be my maximum deflection, and if these criteria are fulfilled, we say that the structure is safe. If the criteria are not passed, we will again evaluate the structure for one more time, and we will comment whether it is safe or not. Okay, you can find much detail about this testing in this code, ACI 437. I hope everyone are clear with load testing and petrographic analysis. In these images also, you can see load testing being carried out on different structures. So this was a bridge on which right now the loading has been kept. Okay, here also you can see a bridge where trucks filled with the load has been kept. Here also you can see lots of trucks have been kept on the bridge to check its deflection. And how we evaluate, either by examining the deflection through optical microscopy, like capturing the image and evaluating the deflection, or by installing strain gauges, strain transducer below the bridge to check how much deflection is happening. Or like here also you can see strain gauge was installed. Here also you can see strain gauge was installed to evaluate the deflection, and manually also to check cracking or something if it has occurred or not. Okay, so in these images you can see how load testing is carried out. Any doubts in the discussion till now in load testing and petrographic analysis?
Can you repeat the monotonic, sir?
Okay, so what we do in monotonic loading, we will, like, I know the total load magnitude. Okay, total load magnitude for which I need to check my structure. Okay, now in monotonic load loading, what I will do, monotonic load testing, what I will do, I will initially apply a small percentage of load. Generally when we are doing load testing, we don't immediately expose it to TLM. We apply load slowly and increase so that we can see the deflection properly. So what we do initially, we'll apply a small percentage of load, say 25% I have applied. Okay, so 25% of TLM. Suppose my TLM was 100 kg, 1000 kg. I will apply 250 kg of load. So suppose I have four trucks, each truck weighs 250 kg. I will place one truck on my bridge and I will keep that truck there for suppose 4 to 6 hours. Okay, now after that I will measure the deflection. Okay, then I will increase the load till 50%. So I have now placed 500 kg load. I will keep it for some time. Then again I will increase the load till 750 kg. I will keep it C for some time and then I will keep it for ultimate load 1000 kg. Okay, once I have reached this TLM, what I will do, I will make sure that the load is there for at least 24 hours. So all the four trucks will be there on the bridge for 24 hours. After 24 hours or during the period of 24 hours, I will measure the deflection. Okay, so suppose here the deflection was very small. Here deflection increased a little. Here again it increased a little. And now after 24 hours, I will measure the deflection. If this deflection is under limit, we will say the loading, it like structure is safe. If it is not within the limit, it will not pass the loading test. After removal of load, again we will check the structure after again 24 hours. Now this is 0 TLM. Okay, zero weight is there. So when I will remove the load, what will happen, my deformation will reduce. So elastic deformation will be recovered. So after 24 hours, I will again check how much deflection is there. So that will be known as my residual deflection. This will be known as my maximum deflection. So based on the limit set, okay, by code, we can check what is my residual deflection, is it under limit, and what is my maximum deflection, and is it under limit or not. Okay, clear now?
Yes, sir, clear.
Any other doubt? Okay, so we will move ahead then. So let's move ahead to the week 3 content now. Okay. Now we know what different distresses are there in concrete structures, how they appear, and how can a structure be evaluated for its present condition. We know that when there is disintegration, degradation in concrete structure, there is decrease in performance of the structure. The same can be seen through this graph also. So here you can see as the deterioration is increasing, the performance of the concrete is decreasing. Okay, so deterioration can affect the performance in two ways. Either it can affect the mechanical performance, that is strength, or it can affect the durability performance. Okay, and as the deterioration prevails, the rate of deterioration also increases. So you can see here slowly, slowly the rate is also increasing. Now, before understanding how to tackle deterioration, it is important for us to clear how strength and durability are different and which one is needed to be addressed and how to address. Okay. So, durability of a structure is the ability of a structure to withstand weathering, chemical attack, and abrasion. while maintaining its desirable engineering property. So this is known as durability, to maintain the performance. And strength is the ability of the structure to resist the loading without failure. Okay. So when we talk about durability, we imply providing measures which can resist damage occurring due to exposure conditions. Okay. I will again re-emphasize on this point. When we are talking about durability, we provide measures which can resist damage occurring due to exposure conditions. And when we talk about strength, we imply to providing measures which can increase or regain the load carrying capacity of the structure. Okay, here we are referring to the damage occurring due to exposure condition, and here we are referring to the damage occurring due to failure of taking load. Okay, I hope everyone are clear with these definition. So, for an existing building which has undergone degradation, there can be three ways in which we can tackle degradation. One more point: are strength and durability directly proportional? While strength can contribute to durability, it is not directly proportional to durability, because a stronger concrete mix may not be highly durable. It also depends upon other factors like proper curing, aggregate quality, and environmental condition. This I can explain you by one example. Suppose you have a reinforced concrete structure, M40 grade. This structure is located very far away from seawater. Now, very far away, the exposure condition are very mild. Okay, so that structure will appear to be very durable. But the same structure, when it is located very near to the shoreline or in contact with the seawater, what happens? My exposure environment is very critical. There is a lot of chlorides, lot of sulfates in contact with the concrete. So the same concrete structure, which was supposed to give me 100 years of service life, very far away from shoreline, may appear to give just 20 or 30 years of service life near the shoreline. So though my structure was having same strength, my durability was not the same. So that's why we say strength and durability may not be directly proportional, though they are related, but they are not directly proportional. Okay, now for an existing building which has undergone degradation, there are three main strategies in which we can tackle degradation. First is repair, rehabilitation, and retrofitting. Okay, so what does each one of them mean? So by repair, we mean to restore the original condition of the structure. So originally at day zero, what was the condition of my structure? I need to restore that condition again. I need to restore that performance again. Okay, how this can be done? It can be done by replacing the damaged element, restoring the lost features, and repairing the system which are not functioning as intended. And the advantage of repair is it is cost effective and quick, because repair will be always be better than to replace. Replacing will be much more costly and time consuming than repair. Okay, and the disadvantage of repair is it doesn't address the age related issue. So in repair we are addressing the issues which have occurred due to weathering or exposure condition, and not due to the aging of structure. Okay, second is retrofitting. So retrofitting is to adapt a structure to a new use. Like suppose I have a three-story building which was initially used as a residential apartment. Now I want to change the function of that building to a office building, or to a, suppose, a mall. Suppose I am changing the function of the structure. Now with the change in function, I the load carrying capacity of the structure may increase. So I need to retrofit the structure to make it suitable for new use. Okay. And how it is carried out? By modifying the existing building to suit the different purpose. And the advantage of retrofitting is increasing the functionality of the structure, while it can be expensive or time consuming also. Okay. And one more thing that you may have heard very frequently is rehabilitations. Okay, so this is the aim of this is to bring us building back to its current standard, up to the current standard of modern features and systems. So suppose new codal provisions have has been passed which have redefined how a building should, how what should be a standard of a building to qualify it for use. So if the standard has increased and my building is still based on the old standard, I need to carry out rehabilitation of the structure. And how this is carried out? By modifying the structure for safety, comfort, and efficiency. Okay, the advantage is it enhances the safety, comfort, and efficiency as we talked in the process. But again, the disadvantage here is it is time consuming and can be sometimes expensive. Okay, so this is just an overview of retrofitting, repair, and rehabilitation. From these definition also, one can simply say like repair is generally carried out when there is some durability issue in the structure. Okay, retrofitting is mainly carried out when the strength of the structure is affected, or when I need to change the functionality of the structure. Okay, and rehabilitation is carried out when the guidelines regarding the use of the structure has changed. Okay, so now we know when we need to think about repair and when we need to think about retrofitting, and what how it is related to durability and strength. Okay, so by remembering and understanding this, one can have a good judgment on site also, seeing the condition and the testing result, which way to go forward. Now, since it is an important junction of this core repair and retrofitting, let's emphasize the same point again through the flowchart. So, what does repair do? Repair increases the durability of the structure while it does not increase the strength of the structure. And the same can be seen as it is slowing down the rate of deterioration. So, here you can see the rate of deterioration after repair is increasing, and you can see the slope of deterioration is again same as how it was initial. So we are restoring the initial condition of the structure here, while my performance, the strength based performance, is left unaffected. While what does retrofitting do? It increases the strength of the structure. Where while it is increasing strength of the structure, it may increase the durability of the structure also. If my location of the structure is not changing, it is on the same location, then as the strength is increasing, my durability also, will also improve, and the same can be seen by the increase in level of performance. So the rate at which the degradation was occurring may not change because my exposure condition is the same and my structure age is the same, but my strength of the structure is improved, so my performance has been enhanced. Okay. Uh, Okay, so for an existing structure for which we need to conduct an inspection, how we consider whether we need to choose repair or retrofitting. So first we go for initial inspection. So in initial inspection, we just examine the structure visually and we collect all the initial information regarding the structure. Then we go for periodic inspection in which we examine the structure again visually, but from at a much deeper level. Okay, once we realize the possible areas where the structure might have been affected or reasons or see several spots of damage, we go for semi-destructive and non-destructive testing, and that comes under detailed investigation. Okay. Based on the obtained results of from the testing, we scale the evaluation in on the basis of five parameters: functionality, whether my structure has hampered its functional use or not; structural safety, whether my structure has endangered the safety of resident or not; serviceability, whether my structure can continue to provide the service or not; appearance, whether my structure's aesthetic has been affected or not; and durability, whether it has influenced the service life of the structure or not. So suppose I am getting a certain data set from the investigation. Now I will evaluate those data set and the visual inspection result based on these five critical parameters, and based on these parameters and the values of the results that we got, an examiner may choose whether he need to go for repair or retrofitting. So suppose he sees the strength has been severely affected and it won't fulfill the functional need of the structure, one will go for retrofitting. And suppose he sees the durability of the structure has been affected or appearance of the structure has been affected, he may go for repair. Suppose he sees the structural safety has been hampered and it is not again not anymore safe as per codal provisions, he may go for rehabilitation also. Okay, so once the choice, based on the cause of distress and extent of distress. When the choice of repairing and retrofitting is done, the next step is selecting appropriate method and material for conducting repair or retrofitting, preparing the existing structure, and then carrying out the process. Okay. And how this choice of selection of method and suitable material can be done based on the visual inspection, the detailed destructive evaluation, and even sometimes the petrographic analysis, or a much microscopic testing that has been carried out. We can uh, uh, identify the cause of the distress, the extent till which the distress has occurred, and what we need to go ahead. Okay, I hope everyone is clear with this slide. It's a like very important slide in the context of this course, and I want everyone to be clear with this slide. You may listen to the recording at least 1 2 times more so that you are clear with this basic understanding of what is repair, what is retrofitting, when to do it, and how to evaluate on site, which we how we need to go forward. Okay. Now, how to choose repair or retrofitting method, we will see later. Okay. First, let's see how surface preparation is done before any repair activity is carried out. Because this was our first part, selection, preparing the existing surface. Okay, this we will see later on. First, we are seeing this, preparing the existing structure before carrying out any activity. Any doubts to anyone? I heard a beep sound. That's why.
Excuse me, sir.
Yeah.
I think so. Repair can also increase the strength of the structure.
Hmm. What you can like please elaborate what was your doubt or what is the concern.
Actually, sir, that I'm thinking that if you repair the structure, it will increase the strength also.
No, you will see later on when we are talking about repair methods now what we are doing. Okay, so from that you will get to know whether it is increasing the strength or just repairing this current state of the structure. Okay, once I will come to repair method, you just visualize again what is happening to the structure and whether it is causing any strength improvement.
Okay, sir.
Please mute yourself no, if you have doubt. Okay, I will move ahead now. Okay, so first let's see how surface preparation is done before carrying out any activity of repair or retrofitting. So the preparation of existing surface is carried out in two steps. First is fixing suitable supports and formwork, and second is first part is to fix suitable supports and formwork. Okay, now how this is done? Through shoring and scaffolding. Okay, so shoring is nothing but providing temporary support to stabilize the structure during construction, repair, or alteration. Here at the bottom of the side, you can see different kinds of support were provided. Why these were given? So that the structure can be stabilized a little before repair activities carried out. Now, these material that we use for shoring is made of either timber or steel tubes, and the choice depend upon the load it must sustain and the duration for which it will be used. Okay, so in the images, in these images, you can do different types of shoring also. There's inclined storage shoring, there's horizontal shoring, and there is vertical shoring. Okay, and the images in the right, you can see several applications of shoring. So here you can see horizontal shoring being carried out for some soil stabilization work. Here also you can see vertical shoring, horizontal shoring being applied. Here again you can see horizontal hydraulic shoring being used. Here wooden shoring was used. Here steel shoring was used. Here you can see inclined metal shoring is used. Here you can see vertical shoring is used. So based on the application and the need, different types of shoring or temporary supports are provided to the structure before carrying out any repair or retrofitting. Okay. Once the shoring activity is completed, after this we go for scaffolding, which is nothing but to provide access to areas for repair, retrofitting, or construction purposes at longer heights. Okay, so these scaffolding materials are made up of wooden planks or metal poles, and these are generally used by workers and act as a temporary structure outside our main structure. Okay, so in the images at the bottom, you can see scaffolding being carried out outside a house for painting. Here you can see scaffolding being carried out, wooden scaffolding being applied to access difficult positions of a bridge or a house. Here you can see again steel scaffolding, steel and wooden combined scaffolding being carried out across a water tank for some repair or construction work. Here also you can see steel pipe scaffolding carried out throughout all across a house, and here also you can see wooden steel scaffolding across a residential building being carried out. Okay. Now, once the structure is provided with adequate support, the next step is which is very important in retrofitting and repair, is the surface preparation of concrete before any application of repair material. So, what we mean by surface preparation? The surface preparation is nothing but the process of conditioning the existing infrastructure to receive the repair material. By conditioning, what we mean? Removal of deteriorated, contaminated, or damaged concrete. So, this step is very important because it has been observed that even the best of repair materials would give an unsatisfactory performance if it is applied to weakened or deteriorated old concrete. So, to make sure that the repair that we are executing it is properly intact with the old concrete, it is very important that we prepare the surface properly and we clean the damaged area properly before a new material has been applied. Okay, now the process of surface preparation is divided into 5 steps. The first step is locating the area that needs to be repaired. How this is done? This can be done either by hammering and listening to the sound, which is also known as soundness test of concrete, or by locating the defect manually, okay, where this repair is needed. Once you have discovered where the repair is needed, the second step is removal of deteriorated concrete. There are several ways in which we can remove the deteriorated concrete based on whether we need partial removal or full depth removal. For partial removal, we can use clipping hammer or hydro remover as shown here and here. While for full depth, we can use a handheld pneumatic breaker or a hydraulic pneumatic breaker as shown here and here. Okay, once you have removed the old concrete completely, the next step is the preparation of surface boundary for repair. So it is a general practice to clear of the damaged area from all the side of the damage with some extra clearance, so that the new material that we are placing is properly intact with the old concrete. So what it is done generally, suppose this was my area which was damaged or deteriorated, but when I will clear off the deteriorated concrete, what I will do, I will clear some extra area also, some specific extra area also, so that when I am placing my new mortar or new repair material, it is properly intact with the old material and it is taking proper shape with the old material. Okay, now this clearance area is usually in the shape of rectangular square so that the repair material applied later can adhere to the substrate properly. Okay, once I've cleared out enough area that is needed to be repaired, the next step is the cleaning the repair surface, and this is done. This includes removing dust, stain, contamination from the damaged area, and this is done either by using wire brushing or using scrabbler, okay, or by acid etching also. Okay, so in different ways we clean the surface properly, and once the surface is cleaned, finally, the substrate is conditioned to SSD state or surface saturated moisture state, so that the repair material can adhere to it properly. So suppose I have a concrete, I have clipped out this area from the surface of concrete and I have cleaned that concrete. Now what I will do, I will make this concrete to be in moist state, so that whenever I'm applying new repair material over it, it will adhere to the structure, the old substrate properly. That is known as conditioning of the structure for proper bonding. Okay. Now, after preparation of existing structure, the next step is to choose the appropriate repair material and apply it. Now, the choice of repair material depends upon several factors. These are: it should be low shrinkage material so that there is no additional shrinkage crack. It should be quick setting so that it won't take much time before again we can start the functionality of the structure or make structure use available for use. It should have good bond strength with the old concrete so that there is no critical failure location at the interface of new material and old material. It should have sufficient strength to so that the amount of material that we have chipped off, it can again, the structure can again go to the original state of the strength that it had. And here is where you can clear how repair is different from retrofitting. Okay, in repair what we are doing, we are not increasing the strength of the structure, we are maintaining the strength of the structure while improving the durability performance of the structure. How? By repairing the defects in the structure. Okay, I hope the one who asked me the doubt about repair will increase the strength, it is clear to him now.
Yes, sir.
Okay. Next property is it should have adequate workability so that when I am applying the repair material, it fills my complete area properly. It should have air and water impermeability so that it does not become weak zone for ingress of aggressive ions from surrounding. It should not be hazardous, and it should be durable and cost effective. Okay. Now, commonly, repair materials are classified into five types. Okay, we will see one by one. The first is cement mortar. So, cement mortar is typically used for repairing exposed surfaces and new concrete surfaces, and it is suitable when the defective area is too wide and the thickness of repair needed is less. Okay, so this is the application of cement mortar when it is generally used and where it is used. So in the images you can see here, the corner of a stair was repaired using cement mortar. Here you can see a spalling which occurred on the surface of a wall being repaired by cement mortar. And here also you can see a lining between two concrete slabs being repaired by cement mortar to fill the gap. Okay. Second material is polymer modified cement mortar. Okay, so in this it is a blend of Portland cement and polymer additives. And it what is the advantage of this material? It offers improved adhesion, flexibility, and durability compared to regular mortar. Okay, in this you can see different applications of polymer modified mortar. This it can be used in the same locations where cement mortar was used, but it is much better than cement mortar, though it may be costly, but it is better. So here you can see a cracked or a spalled location at the corner of a wall or a column being repaired using PMCM. Okay, here also you can see spalling of cover was repaired, and here you can see spalling of some concrete cover being repaired by polymer modified cement mortar. Third is epoxy resin, which is most generally used material for repair. So these are moisture sensitive and have excellent chemical resistance, and they are generally used for structural repair, especially in areas where there is high risk of abrasion and chemical exposure. So epoxy resins are basically a combination of resin and hardener which are applied to fill the cracks or the voids or micro cracks, anything to make the structure again regain the durability without affecting the strength of the structure. So here you can see sparred location on the floor deck been repaired using epoxy resin, and here also you can see uh, epoxy being used for filling the crack. So this method we will discuss later on also what they are doing. Here you can just I right now you can I will just tell you it is an epoxy resin which is used to repair the crack. Okay. Apart from this, there is low viscosity epoxy sealing compounds which are also used. These substances are generally used as a gravity feed for cracks in horizontal concrete and masonry to support Suppose I have a crack or a spalling or some damage on the floors. So where there I can use low viscosity epoxy sealing compounds, which I can just fill in those crack, and it with the help of gravity and just little compaction, it will fill the area properly. Okay, and it can also be used as a low pressure injection for cracks in structural concrete and masonry blocks. So here you can see how this low viscosity epoxy sealing compound was used near surface for filling the structural crack, or it was used as a sealing compound on the floor also. And finally, we have silanes and siloxane based sealing compounds. So these are like penetrating breathable sealers which are designed to reduce damage and deteriorations, more specifically, which are caused by water absorption. So the places where water penetration is the major issue, there we generally use silane and siloxane based sealing compound for repair. So these are generally used as a water repellent and waterproofers. Okay, these sealers are also have excellent performance against freeze thaw damage and salt degradation. Okay, because both of them are based on water penetration, so they perform excellent in those conditions also. Now, what how they action, they penetrate deep into the surface of concrete and masonry, and they chemically react to form some hydrophobic barrier within the pores, which causes water and other liquid to bead off the surface. So when I am applying these siloxane and silane based sealing compound, they will form a hydrophobic coating, or they on the surface of the concrete, or they will block the pores or the cracks of the concrete in such a way that my water won't be able to penetrate. Okay, here you can see when I have applied a silane or siloxane based coating on the concrete, my water droplets, it is just staying on the surface, it is not penetrating the concrete surface. Okay, and these materials are generally used in municipal jobs, highways, and bridge repairs cases, where my damage due to water ingress can be a critical issue. Okay, any doubt? I hope everyone is clear with surface preparation discussion and different types of repair material. Uh, just wait, I am hearing some beep. I guess it is clear. Will it increase the strength? Which material are you talking about, Mr. Kumar? Which silene? No, it is just like a crack filler. So it will decrease the porosity basically. Some like little bit strength can be improved since the porosity is decreasing, but its main purpose is to repair the crack or coat the surface with a repellent material due to which my aggressive ions or salt may not ingress. Okay, the main purpose is filling the crack or coating the surface with a sealing compound.
Sir, how to address the issue of spalling of concrete from the ceiling surface?
We will see slowly, like when we'll talk about different repair techniques, Edna, you will see in how different
Okay.
ways we can address the spalling.
Because in this case, both the problems is happening. From the top, water leakage problem is there, and from the bottom, there is a scaling of total plaster.
In which case,
Suppose a slab, suppose in a stair slab in the headroom, suppose you can guess, it is resting on the masonry structure. Okay. So from the bottom, normally in these staircase slabs, nobody takes care of those things.
yeah.
So gradually, because of seepage and leakage,
Hmm.
this bottom reinforcement is getting corroded and swelling of concrete happens. So
Okay.
how to address this type of issues? This is a common problem in residential quarters.
So what you can do initially, if you see spalling of concrete has occurred, so you can use suitable repair material first to regain the shape of the concrete again properly and cover the reinforcement again. Once you have applied the spalling, if you see that this leakage is constant problem and it will occur again, we can coat the surface of the concrete with a sealer compound or a protective coating, so that again there is no water ingress in the concrete and my strength of or the performance of the concrete is restored. So, in the discussion ahead, we will see that case also when the spalling
Okay,
has
sir.
occurred and my reinforcement has been exposed. So, based on the severity of the exposure or the condition, how we choose different, or how we combine different repair that can be carried out.
Main issue is, sir, with for the strength of the slab, because actually on the underside of this slab the reinforcement is severely corroded. Then how
Has,
to and reinforce it and make it stronger?
uh,
That is the main issue.
that is the thing I'm saying. Na, let's just move
Okay.
ahead in this session. That will come. Just to say right
Okay, sir.
now, if the reinforcement is severely corroded, okay, you are seeing the
Yes,
tensile
yes,
strength
yes,
has
sir.
been affected. Generally,
Yes, sir.
what is done? Additional reinforcement is provided. Okay,
Yes, sir. Yes, sir.
that can be done. And
Okay.
now, since the strength has been affected, what you can do? You can think about retrofitting also. Okay, if your
Okay.
repair is not sufficient to regain the strength, we can go for some retrofitting also. But that thing, how to choose that, we will see in the discussion ahead. What issue that you
Hmm.
have highlighted, it is the part of my discussion. Slowly, slowly, we'll
Yes, sir.
understand everything.
Yes, sir. Yes, sir. Okay.
So, like right now, I have tried to lead a deep emphasis on these points, like what is this material, where it is used, and how it is used, because all these things may not be very clear to you in the recorded sessions of the week 3. And these small points that we have talked till now, it is very important for us to understand right now, so that we can understand the things that are coming ahead very properly and in an oriented manner. Okay. Any doubts? Any other doubts? If not, we'll see ahead. Okay. I will pause for 1 minute and then we'll continue. Okay. If anyone has any doubt till the discussion till now, just write in the chat box. Okay. I am pausing for 1 minute. Okay. So let's see ahead. Okay, now let's see an illustration so that everyone are clear with whatever we have discussed till now. So let's see an illustration on how diagnosis and repair treatment is carried out on a damaged concrete structure due to corrosion. Okay, so my first step will be identifying the distress. In this, when I'm talking about corrosion damage, the key observations that I can draw from visual inspection would be appearance of longitudinal cracks. So a longitudinal crack may be visible during the visual inspection, or some rusting stains may be visible. There may be spalling or delamination of concrete cover that you can spot, or if the damage is very severe, you may even see that the reinforcement has been exposed with deposition of corrosion product, and its area has also been affected. Okay, so here you can see smelling and delamination, but here you can see a severe corrosion product formation has also occurred on the reinforcement based on the denseness of the corrosion product that is lying there. Okay, so these can be a key observations during visual inspection, which may help you to identify what may be the reason behind the distress. Now, once you have conducted visual inspection, what you will do, you will again you will go for a detailed investigation. Okay, in detailed investigation, what we do, we carry out some semi-destructive or non-destructive testing. Like you will use half cell potential to see what are the critical locations where corrosion damage has occurred. You may use resistivity measurement to see the extent of damage based on if there is a lot of cracking inside the concrete, my resistivity value will be affected severely. So based on that also you can judge how severe my cracking is inside the concrete. And also you can look for carbonation depth measurement if you want to distinguish is the damage that has occurred is it is due to chloride or due to carbonation. So what you can do, you can drill hole, you can collect some do carbonation depth measurement to identify whether carbonation damage has occurred, or if you want to guess that is was it due to chloride ingress, you can always go for taking samples from different depths on the concrete and conducting laboratory testing, like estimating chloride content in concrete sample and all those things to check how much chloride has been ingressed and which one is dominating. Okay. Also using a half cell potential map, you can half cell potential you can create corrosion counter maps so just to locate which all regions are severely affected. Okay, here you can see carbonation we have talked about, longitudinal cracking we have talked about, and half cell potential measurement they are carrying out. Here resistivity was carried out from a core sample taken from the structure. Okay. Now, once we have identified the locations and made the choice of that we want to go for repair. Okay, right now I'm talking just about repair. So we have made choice that we are going for repair, and we have identified locations like these are the area where I need to go for repair. So since there are major spalling occurrence which are observed, while at some places the rebars are also severely affected, my next step will be divided into two things. First will be the surface preparation near corroded area. So I will prepare that. I will first chip off the loose concrete. Then I will remove concrete from all sides of the damaged rebar, and then I will clean the concrete properly, the removed concrete properly, and my damaged rebar properly. So in the images also you can see for removing the loose concrete, we can always use high pressure water injection or abrasive blast cleaning or wire brushing from near reinforcement if you want to remove the concrete. For chipping of loose concrete, we can use some hand drill tools and okay. And once we chip off this spalled area of concrete, we'll clean the concrete from all the sides so that my below the reinforcement is also accessible and my proper place is available where I need to apply the repair material, and then I will clean this rusting over the concrete. Okay, using water injection, abrasive blast cleaning, or wire brushing, anything. Now, for locations which has undergone severe reinforcement damage, suppose a lot of rebar cross section has been lost. I have found places like that also. There, I can go for providing additional reinforcement if necessary. Okay, now how to choose where these locations are? Okay, we can choose this location by evaluating the effective length. Okay, so suppose if the reinforcement steel has lost more than 25% of its cross section, then additional reinforcing steel may be required. Okay, so here you can see this rebar lost a lot of cross section. So for this portion I provided a overlapping supplementary bar attached to it so that it can regain its tensile property. Why we are doing it? To restore the tensile strength of reinforced concrete. Okay. Once we have removed the concrete and cleaned the affected rebars in terms of the corrosion products that was there above it, and in terms of the effective length by providing additional reinforcement, the next step is to prepare the concrete surface, the substrate properly before application of repair. Now, what are the key properties in this? So the key properties is roughened profile of substrate with open pores. So for different types of repair material, different amount of roughness in the substrate is required. Why? So that my new repair material can properly bond to the old substrate. Now in the image below, you can see a roughness scale which is divided into 10 level. So suppose if I am using concrete overlay as a repair material, I need to have roughness of this scale. For polymer overlays, I need to have roughness of this scale. For self healing leveling topplings, I need to have roughness of this scale. For high build coatings, I need surface of the scale. Thin films, for I need a much smoother surface. And for sealers, when I talk about sealer, for them I don't need a much rough surface. But when I'm talking about polymer overlays or mortar, concrete mortar as a concrete repair material, I may need a very rough surface. Why these are needed? So that it can properly bond with the substrate in terms of shear properties also, and in terms of proper interlocking and tensile bond also. Okay. So in this image, you can see how a rough surface will bond properly with the new material. Okay. Once we have reached the proper roughness profile of the substrate, I will make sure that the repair material that I am using has sufficient paste in it, so that it can easily fill the pores of the repair material and interlock with the substrate. Okay, it can easily fill the pores of the substrate and interlock properly. Okay, and I also need to make sure that the repair material that I am applying, it is applied very in a pressurized manner, so that it is compacted well also, and it regains some shear interlock with the substrate. Okay, once my surface is ready for repair, the next step is to apply the repair material. Now, this can be done in various ways depending upon the crack depth, the severity of concrete that was damaged due to corrosion, and the severity of reinforcement damage. So, we can classify this in different cases. So in case one, you can see when the crack is very narrow and extending beyond the reinforcement, what we can do, we can simply go for some crack sealing method, where we are just sealing the crack and then we are coating the surface with a surface coating materials with a sealer. Okay, this can be one case. Second case can be when my crack is a little wide. So here my crack was very shallow. Here my crack is very wide. Okay, my crack is wide, but it is only near surface. So in such cases, what we can do, it's better to chip off the cover concrete till below the crack, fill cement mortar or polymer overlay or epoxy overlay on the surface, and later apply the surface coating. So here we are not filling the crack with a resin or something. We are just chipping off the concrete and placing new concrete over it, and then surface coating the concrete, so that if my deterioration conditions are severe, it won't affect my new concrete soon enough again. Okay. Third case can be when my crack is very wide and it is extending beyond the reinforcement such that my rebar is being exposed. In such cases, what we need to do, we will first clear the chip. We will first chip off the complete cracked concrete. Okay, till below the reinforcement. We'll apply the repair material and then we will apply the surface coating. Okay. Now, in case 3, if it is observed that my rebar is severely damaged, it is not undergone like severe pitting or cross sectional area loss, but we can see a lot of uh, corrosion product was formed and it is uniformly formed over that defected area. So we can also go for some corrosion protection methods like cathodic protection or use of corrosion inhibitor. This we will see later on. Okay, this part will come later on, so it will be clear to you how to choose that. And once we have applied the corrosion protection method over the rebar, we can then use repair material, maybe cement mortar, or better to go with the polymer modified mortar, and then we can surface seal the concrete. Okay, so you can see in these 4 cases, based on the crack width and crack depth, how we choose different types of repair being carried out. And in all the cases, we sealed the surface with a coating so that my there is an additional layer of protection applied to the damaged area. Okay. Sometimes instead of using repair mortar as a slurry, if the crack is not extending beyond the reinforcement, we can also go for dry packing. So in this, what is dry packing? So dry packing is just a low water to cement water percent cement mortar which can be prepared, which when prepared after mixing will appear like a lump, a low viscosity lump. And this lump, how it can be used to repair the crack, this lump can be placed on the spalled concrete and it can be hammered for proper compaction and coverage of the damaged part. So in the image also you can see the base of a wall. Okay, it showed spalling. So what we did, the spalling was just near the surface only, and it was still above the reinforcement. So what we did, we used dry packing. We applied the dry pack here, and we compacted that with the hammer, and then from above we can seal it with the epoxy, with a sealer material, silane, siloxane, or anything. Okay, so in this way also we can do, instead of going for slurry mortar and a like more flowable material, we can also use a dry pack material also if needed. Okay, I hope everyone are clear with this problem that we discussed recently. Any doubts?
Sir, how to address the issues with the conduit pipes? Okay. Hello?
Right now actually we are talking
Ah,
about concrete repair. With pipes we will talk later. Okay, this every
o-
discussion right now is concrete repair.
okay. In this case, suppose in a ceiling case, when it is coming for the ceiling, how
Hmm.
to put the reinforcements? What is the methodology?
So we can basically tie the reinforcement, the affected area which has been damaged. So suppose like in this image, okay. Suppose I need a pen. Suppose my rebar is like this, okay. I can spot a location where severe pitting damage has been occurred, and I know
Okay.
that this can be very critical now for tensile failure. So what I will
Okay.
do, I will clear the concrete till here, okay.
O-
I will put a additional overlapping reinforcement here and I will tie it with the old reinforcement. So what this will do, it will help me to regain the tensile strength here at the critical position. Now once I have applied the additional reinforcement and even I can coat this reinforcement again with the protective coating to make it more protective against external event. Once I have done this, I will apply my repair concrete and I will seal this.
So that is the only difficult part, sir. How to place? Practically, actually, we are not getting any clearance. Suppose we want to any clearance, then again we have to damage the surface. Suppose the thickness of slab is to 4 inch only, then with that actually it is further getting damaged up to the top surface.
I didn't understand your point.
Actually, what you said that the bottom surface you will clear and put a reinforcement.
Hmm.
Okay, you can tie with the existing bars.
Hmm.
Actually, practically that is not happening.
Okay.
Even suppose we will drill somewhere, then again leakage issue is coming.
Okay.
So, is there any technology that we can address to this type of issues?
I will look into that because it is
Because
like a specific problem that you're talking about where you can't clear a much area. You have a small area only that you need to repair, and that such repair is not possible. That you're saying, right?
yes, yes, yes.
So like, give me time. By next live class, I will tell you the solution for this also.
Because sir, you just see, suppose a
Hmm.
reinforcement in a reinforcement area, suppose 50% of the reinforcement is corroded,
Hmm.
then actually it will be very difficult to put reinforcement there in that particular area. In that case, how to address these issues?
Okay, I will check on this. Okay,
Because
I also need to think now. What?
neither you can weld nor you can drill. That is the main issue.
Okay, I will get back to you with this with this problem
Yes,
later.
yes, sir. Yes, sir.
Okay.
Okay, okay, sir.
Hmm. Any other doubt? Okay, so till now we have talked about sealing cracks, okay, and all. Okay, if my crack is very narrow, like mainly broad cracks, when we have, so we talked about how we can place repair mortar or polymer modified mortar just to cover that sparred area and everything. Now on site, what happens? My crack can extend to the surface, or it may be internal also. Some crack that are coming till surface may be very wide, which takes shape of spalling or delamation, or some cracks can be very narrow and distributed also. So for ease of application and repair of these for ease and effectiveness of repair for filling these cracks in concrete, usually grouting is used. Okay, so what do we mean by grouting? So grouting is nothing but process of injecting grout into cavities and cracks in concrete. And grout here is nothing but a slurry of repair material which can flow through pipe, or which we can say as which can be injected into the cracks. Okay, now how grouting repair is carried out? So there are four steps. First, we will drill grouting holes. Okay, then we'll arrange grouting pipes. Once you have arranged grouting pipes, we will clean the cracks using water, and then we'll insert the grout material through the holes. Okay, these grouting can be used in repair techniques in cracks and concrete also, and it can be used in other applications also, like filling gaps in tiles, sealing joints, soil stabilization, and foundation strengthening. Okay, now when we talk about grout that is used as a repair technique, it is mainly classified into three primary categories. Okay, first is cement grouting. So these are generally used to fill underground voids, and in concrete they are used when honeycombing is there. Okay, or in masonry they are used for hollow patches. Okay, in the images you can see here grouting is carried out below a steel rebar to fill the honeycombing area. Here you can see grouting pipes has been installed to uh, clear the cracks or the underlying cracks or the surface cracks present on a concrete road surface. And here you can see cement grouting being carried out for subsoil stabilization. Okay. Apart from this, there is chemical grouting. So these chemical grouting are composed of solution that behaves as a fluid initially, but after some predetermined time, they will solidify in the form of solid, semi-solid, or gel. Okay, so examples of chemical grouting are polyurethanes and acrylates or epoxies, and they are mainly used for soil stabilization purpose, or for purposes where we want to control the water leakage also. So in the images you can see chemical grouting has been applied for subsoil stabilization or at the surface for crack repairing and for controlling the water leakage problem. Okay. And we have epoxy injection grouting. So epoxy injection is nothing but a combination of resin and hardener that has been injected into voids under pressure. So how this is carried out? So across the length, different channels or ports are created, while the crack surface is covered with a sealer. So here what we are doing, we are installing different ports or channels across the crack, and then we are sealing the surface. Okay, once this is done, we will inject our epoxy grout through this crack so that they can fill through this channel so that they can fill the cracks. And later on, when the curing period is over, the surface sealers will be removed and our cracks are filled or cured. Okay, so these are different types of epoxy grouting, different types of grouting. Now, from application point of view, there are different ways in which grouting can be applied for repair purposes. So these are mainly classified into four types. First is drilling and plowing. Second is pre-placed aggregate repair, stitching and stapling, and routing and sealing. So let's see each one of them quickly, because this was discussed in detail in the week content also. So we will discuss it just quickly through the images. So in drilling plowing, what is the when it is used? What is drilling and plowing? So it consists of drilling down the length of the crack and grouting it to form a key. So when it is used, when the crack is runs reasonably in a straight line and it is accessible from one end. So suppose my crack in a straight line and it is accessible at the surface from one end, then we can go for drilling and plugging method. And it is most oftenly used for repair of vertical cracks in retaining walls. So in this, what it is done, we'll drill down a hole through the length of the crack. Okay, and then we will grout it to form a key at the surface, and then we will place a key on the surface to close the crack. Okay, the key may be made of a precast concrete or mortar, and it will close the crack. Okay, so here in this image also you can see, once first drilling was done, then grouting was done, and then a key was inserted, and then the crack was sealed at the surface also additionally. And in this image also you can see, for a retaining wall, drilling and plowing is carried out. This is like horizontal drilling and plowing that has been carried out here. Okay. Second method is pre-placed aggregate concrete. Now, in this, what it is done, coarse aggregate are densely packed into a formwork, and then grouting is done through pipe from bottom to top. So, in this, you can see there is a affected area. So, that affected area was surrounded by a formwork. Then, coarse aggregates of various sizes was placed inside the formwork, and they were densely packed. Even after densely packing, there will be voids between the aggregates. Okay, now what I will do, I will insert a grouting pipe till the bottom of this state, and I will inject the grouting material. So my grouting material will fill the gaps between the aggregates, and it will come from bottom to top, and it will completely pack my corroded surface. So, such repair is generally used when conventional concreting is difficult to be carried out, where it can be the case, like areas where high reinforcement is present or underwater concreting needs to be done. Okay, when my concrete knee of a bridge which is directly contact in water, that surface of the concrete has undergone severe erosion, like uniform degradation at the surface, and I want to again restore the cover of the concrete. Then what I can do, I can place formwork, and then I can place aggregate inside, and then I can inject grouting from top to bottom, and I can repair the structure. In both the cases you can see this has been carried out, and this shows pre-placed aggregate concrete when used for repair of a retaining wall also. Okay. After this, we have routing and sealing of crack. So in this, what is done? This is a very commonly used technique, and what we do, we first enlarge the crack from along the exposed face, and then fill and seal the crack with a suitable joint sealer. So in the image you can see, originally there was a crack along the surface of the concrete. Using a grooving or a chipping tool, what we did, we enlarged the crack, and then we filled the crack with the repair material, and then we applied the joint sealant material. Okay, and such techniques are applicable for any kind of cracking pattern. The crack can be horizontal, vertical, or curved. It can be narrow to wide, anything. So it is very simple and cost effective and very commonly used for repair purpose. So here you can see a pavement, cracking on the pavement being repaired using grouting and sealing. So you can see different patterns of crack happened, and all has been sealed using grouting and sealing. In these areas you can see cracks was there, and how routing and sealing has been used to fill those cracks. Okay. Now, sometimes my new crack material that I'm filling in the cracks, it may show shrinkage effect or contraction or expansion due to temperature changes. It can also occur due to which my new material can crack. So, in such cases, what is done? Bond breakers are also used. In addition, the bond breakers are placed at the bottom of the crack, and then routing and sealing is done, so that there is no additional cracking in the prepared material also. Uh, okay, so after this, there is stitching and stapling. So in this is the most easiest and long-lasting method. And in this, what is done? Several holes are drilled along the crack surface, and then in this holes, metallic U-shaped wires are then inserted in the holes and anchored strongly in the holes with the help of grout or epoxy bed sealant. So I will show through an image. Suppose I have a pavement where I have received such cracking. Okay, and now I want to repair this crack. So what I can do, what I will do, I will drill hole. So if I see from the side view, this is my surface, and here the crack happened. So I will drill hole, okay, along this length, so that it is crossing the plane of the crack. Okay, this is my plane of the crack. I will drill hole in an inclined manner so that it is crossing the plane of the crack, and I will insert metallic wires, staplers like wires on the top, and I will fill this hole with epoxy grout, so that it can seal the crack properly, and it won't allow the crack to propagate further, and it will resist the propagation of crack. Okay, so in this image you can see stitching and stapling repair was carried out to repair a pavement surface. Okay, now it is important for us to understand here that each of these method has their suitable area of application, and the right choice of the can be made thereby for which method to use. So in case of pavement and road surfaces, cracks often result due to thermal gradient or excessive loading. Okay, so in such cases, we can see which crack, how to repair. Or in case of walls, if there is some cracking, we can see which method we can go forward with. Or in case of difficult areas of access, which method we can go for is. Or if the crack is only single oriented, single direction oriented, which method we can go for. Okay, now additionally, for roads and pavement surfaces, cracks can often result due to thermal gradient or loading, and we saw how to identify and address those cracks. But however, since these places are constantly under the threat of further weathering, either due to wear and tear, which can be caused by abrasion, or due to water ingress, sometimes there is a need to provide an additional top coat on the surfaces also for protection. And these coatings are mainly classified into two types: thin polymer coating applied over the concrete surface. Okay, so these thin polymer coating consist of primer coat and a sealer coat, and these are generally used in areas where there is high abrasion risk. And there can be thin epoxy overlay also, which consists of resin and hardener, and they are mainly used in area where there is major problem of water ingress or water penetration. So these are some additional protection also which we can go forward. Now, till now, we saw distresses like cracks or localized disintegrations like spalling and delamination, which occurred. However, when there is a bulk surface disintegration, which results in spalling, or when the concrete surface has undergone major erosion damage at several locations, or when there is severe abrasion damage all over the surface of the concrete, shotcreting, or we can say gunneting, is used. Okay, now what is this? So shotcreting or gunneting is a deposition of concrete or mortar as a layer over the substrate through pressurized flow without the need of foam work. Okay, so in this, what is done? Concrete and mortar is applied as a additional layer over the substrate in the form of a pressurized application, and here no foam work is required. Okay, and where these such things are useful when we want to restore spoiled surfaces. Okay, so shotcreting can be done in two ways, either in dry mixing or in wet mixing. So in dry mixing, water is just added before the application of repair material to the concrete surface. And in wet mixing, as the name suggests, water is pre-mixed and then applied. So the images below will clarify these processes further in a better way. So in dry mixes, you can see initially there's a pre-bagged shotcrete material that is added in the hopper, and then this dry material, with the help of a shotcrete gun and a pressurized air compressor, is pressurized through the pipe till the nozzle head. At the nozzle head, the water supply is attached with another additional pipe. This water will mix with the dry material here at the nozzle head, and it will be applied in the form of spray to the concrete. Okay. And in wet mixing, ready mix trucks are present which will mix my repair material. This will load my repair material in the concrete pump, and with the help of an air compression through pipe, I will directly apply this repair material on the surface of my damaged concrete. Okay, so the images shows both type of concreting here. So in the first image shows dry shotcreting done on the wall of the swimming pool. How it is dry? We can see there are two pipes. This is the water pipe and this is the dry mix material pipe, and it is used on the walls of a swimming pool. It can be used for repair also, and it can be used sometimes for construction also when I want to go for a thin layer construction purpose. Okay, while the second image you can see wet shotcreting was done on the tunnel wall lining. Now, one may wonder what is the difference between both wet and dry in terms of quality and application easiness of repair. Okay, so dry shotcreting generally requires lower investment. Okay, it has much better bond strength and it has less wastage of material because it that dry material is flowing through the pipe and it is directly applied on the concrete. So initially in the mixing truck my material won't waste much, but since there are two controllers during the application, it may require more labor. Here, the quality of the material that I am applying will depend on the spray man. Why? Because he is the one who is controlling how much water will be mixed with the dry material, and that can change the water to cement ratio, which can change the strength of my material that I am applying. Okay, now here if I want to add some admixture like set hardening or set retaining admixture, accelerating or retaining admixture, it is difficult here because one person is only controlling everything. Okay, and since my dry material is sprayed here along with the injection mixing of water, there can be dust emission also near the pipe, which can be an issue to the person who is spraying. While in wet mix shotcrete, pumping requires higher control because I'm pumping a concrete now rather than a powder, so it may require a higher control and higher power. Wet mix concreting generally has shown to have lower bond strength and tensile strength. There is more wastage during mixing in the pre-mix ready mixed truck, but here the cost of labor is less because only one man is required for shotcreting. My water content is more controlled in a precise manner. I can add the admixture initially in the design, which I was not able to do in the dry mix. And here the air content will also be less since my material is initially mixed and not near the pipe. Okay, so in this way, both type of shotcreting can be different. Now, there are certain places where grouting or shotcreting are also not possible. So here we use ferrocement as a for repair purposes, mainly for surface repair purposes. Okay, so what are these ferrocements? So these ferrocements are nothing but thin walled concrete where cement mortar is reinforced with multiple layers of wire mesh, and this wire mesh is connected with the substrate with the help of nails fixed by epoxies. And what makes ferro repair a suitable material? It is versatile. It can take any shape and size, but it has low strength because this is very thin. And since the cover is very low, it can also show durability issues like corrosion of the wire mesh. Okay. Now you can see in the images, these two images, different types of wire mesh can be used. We can use simple wire mesh also, or we can use steel calatin also, and over that concreting can be done as a ferrocement repair material. Okay, any doubts in grouting application, shotcreting and ferrocement repair? I've discussed all these things in a like very quickly and just like an overview because these were discussed very deep in the course content, and it is a very simple. All the things are very simple and can be clearly seen through images also. So that's why I've added more images and less text explanation so that everyone are clear with the application. Any doubts till now?
Sir, what is that ferrocement concept?
So ferrocement is nothing but like a thin walled concreting. Okay,
Okay.
like here what we do, we apply a wire mesh and we apply concreting over it and we cover the concrete. So sometimes you may be confused like it is strengthening the structure also, but it is not like that because those wires or the steel that we are using inside it, they are very thin. They are just acting like a cover or a providing the cover to the spoiled surface again. Okay.
Okay, then this will be micro concreting we are using, na? In this case.
We can use micro concreting or like a slurry kind of material also.
Okay, ठीक है. Polymer concrete anything. Okay,
We can use like
okay, sir.
grouting. In grouting also we are using slurry which can flow. Okay, here that
Okay,
slurry may not be that low viscosity. It may have a low viscosity such that it can just coat the wire mesh properly.
okay. Baby chips will be there.
Huh.
Okay, okay.
Okay. If anyone has any further doubt, they can write in the chat box. And those who don't have any doubt, let's see these three practical problems. So I have three different kinds of distresses that I have listed in these three questions. Just think how you would repair, how you will go forward for repair of these three cases. Okay. And for others, you can write your doubts in the chat box. I will pause for like couple of minutes and then we'll start again. Okay, let's see the solution now, since we need to discuss more topics also and time is less. Okay, so in the first case, you can see there was like cracking and almost falling of some concrete from the corner. So how we can correct this? So what we'll do, we will clear off all the loose concrete here. Okay, and we will make a proper clearing surface, and then we can apply like dry packing material also, since it is like horizontal surface. We can apply dry packing material, any suitable uh, cement mortar or even polymer modified mortar we can apply, and we can give it a proper shape, and we can repair this kind of crack like this. Okay. Now here you see a town hall roller skating platform having severe surface disintegration. So what we can do here, we can simply use a low viscosity mortar, or suppose this has undergone such defect has been there throughout a large area of the platform. So we can go for that dry mix shotcreting also we can do on the surface to seal the crack and to even the surface again. And since these damage might have occurred, if these damage was occurred due to abrasion, then we can apply proper sealing over the surface which can resist abrasion. And if it has occurred due to water ingress or due to freeze throw action, we can use epoxy sealers on the surface to seal the surface so that the crack doesn't occur again. And the third case was unevenness caused in the concrete slab. There you can see one there is the settlement in one of the slab here. Okay, due to unevenness, which due to foundation settlement beneath it. So this will come later on also in the content slab jacking. Okay, but right now I will just explain you quickly what is done. So this is my slab here. Okay, and there is one more slab like this. Okay, which has undergone some like depression. Okay, and there is some voids beneath which has created, which has led to this depression. Okay, some settlement. So what I will do, I will drill hole here, okay, on the top, and I will do concreting. Okay, grouting. I will fill this soil beneath with concrete so that my slab will again raise up to the level, and then I will apply a surface coating on the top. Okay, so that there is no ingress of any harmful chemicals from the outside. And this way I can level the surface again, and I can protect the repair this problem. Okay, now you may also go for some other repair technique, but this is my point of view how it can be done. So you just need to develop the thinking of how repair can be carried out in different cases.
But in this roller skating cases, sir, actually nowadays this polymer motor is available.
Hmm.
High resistance polymer motors are available, but it is too costly. Is
Okay.
there any economic method of
So if
doing
it
this?
is too costly, you can simply go for like shotcreting. If the damage is thoroughly across the surface, a large area of surface, you can use a simple shotcreting method to just cover the surface with a thin layer of concrete again, which can cover the surface uniformly everywhere.
Okay, okay, okay.
Okay.
Yes, sir.
Now we will see ahead. Okay. So till now we discussed about concrete repair. Okay, concrete has cracked, concrete has undergone spalling and everything. Okay, but in reality, when we are talking about reinforced concrete, as we saw earlier, there can be cases where my steel has under also needs repair. Okay, along with the cracked concrete. So, and this leads us to discuss specific repair techniques for corrosion damage. Okay, so, where is such case possible? When my exposure condition is very critical threat, or when the reinforcement has undergone critical damage. So, as shown in the image, when there is a corrosion damage, what happens? First, there is a cracking inside the concrete. Okay. Now, due to buildup of corrosion product, on the surface of the concrete, my crack will expand. Okay, and it will take a bigger shape, and as soon as my steel reinforcement is more uh, freely available for aggressive ions from outside, it will corrode more and it can be more severely affected. Okay, and when this state has been reached, suppose I am applying just covering the crack, it may not be suitable because my exposure is very severe. So it will again crack the concrete soon, and it will again demand for repair. Or suppose my reinforcement has undergone like uniform damage, and it needs some control method which can just make sure that this damage won't propagate further. So for that case also we need a suitable repair technique for corrosion damage. Okay, so in the images here you can see like structure near shoreline under spalling zone. uh, we can see how much eroded it has occurred. Or in this image you can see a bridge where severe corrosion damage has been occurred. Okay, in this also bridge deck you can see where severe corrosion damage has occurred, and the complete surface has been spoiled. So here just concrete repair won't be sufficient. Okay, I can give you some examples also, like for structure near shoreline and which is under splashing zone. For example, the bridges that pass over water, like Bandra Worli ceiling in Mumbai. In this structure, what happens? Even after concrete repair, degradation is a critical threat, which may again demand repair very soon. So it is much better solution to repair, to provide some repair technique for reinforcement also along with concrete. Okay. Now, before seeing these repair technique, one must be clear how corrosion can be tackled. Okay. So if we see the process of corrosion through this block diagram, there are two cells when we are talking about corrosion. Okay, the anodic half cell where oxidation occurs, iron is converting into iron plus 2 state and releasing electron. And finally, here the corrosion product formation also occur when iron reacts with hydroxide ion to form rust. Okay, now these electrons that are generated over the anodic half cell, they transport from within the metal, okay, from anodic side to the cathodic side. The cathodic half cell is the site where oxygen, which is penetrating through the concrete, will penetrate till the steel surface, and now the oxygen will consume electron and form the hydroxide ion. Okay, now since these two reactions are occurring at the metal surface only, the electrons transfer will occur within the metal only from anodic side to cathodic side, and these ions that are generated on the cathodic side, they will move from one place to another through the concrete medium, where the fluid filled pore matrix will act as a electrolyte for ion transport. Okay. Now we can from here we can understand where corrosion can be controlled. Either we can lower the rate of anodic reaction, which will lower the rate of corrosion, or we can lower the rate of cathodic reaction, which may again lower the rate of corrosion, or we can make concrete more resistive for ion movement, which will reduce the rate of corrosion. Because since metal is a conductor, the transport of ion will occur inside the metal, and then that we can transport of electrons will occur within the metal, and that we can't control. We can control these three steps. Okay, so based on this, corrosion control is divided into three categories. Cathodic process control method, which is also known as passive treatments because these are applied outside the steel. This includes methods like proper designing and detailing and coating on the concrete surface. So by proper designing and detailing, we mean I will decrease the porosity in my concrete, or I will use supplementary cementitious material which will form a more dense concrete, which will reduce the rate of ingress of ions to the concrete. If the rate of ingress of oxygen will reduce, the rate of corrosion will reduce, because corrosion is a combination of both anodic and the cathodic reaction. So even if one reaction rate is reducing, the whole reaction rate will reduce. Okay, and coating on concrete surface, any water repellent coating or hydrophobic coating, if we do on the concrete surface, it can act as a barrier for ingress of aggressive ions. So these come under cathodic process control method. Again, we can have anodic process control method, which are also known as active treatments because they are done directly on the rebars. These includes method like electrochemical treatment. This we will discuss today. Corrosion inhibitors and coatings to reinforcement. These all three things we will discuss now. Okay, and there can be additional treatment in terms of metallurgical control method where we can use special reinforcement. What are the special reinforcements? Stainless steel and corrosion resistant steel. So how these reinforcements are special? Because they have higher chromium content inside them, which makes them more durable in terms of their performance only. Okay. Now, first method that we'll discuss here is cathodic protection. So the basic of cathodic protection is making reinforcement act as a cathode. Why? Because since corrosion is an oxidation process and it occurs at anode, so if we can make steel to act as a cathode, reinforcement to act as a cathode, the corrosion won't occur. How we can do this? Either by connecting the steel reinforcement with another metal which have higher tendency to corrode with compared to steel, like this. Suppose this is my reinforcement, okay, and I am connecting the reinforcement with another metal, okay, which has higher tendency to corrode. So what will happen in between them? This will form uh, positive terminal, this will form negative terminal. Here cathodic reaction will occur, here anodic reaction will occur, and this will corrode because electron flow will occur from here to here. Okay, and this is known as sacrificial anode cathodic protection. Now, how to choose which metal will corrode? It is based on the potential, okay, which has the higher tendency to corrode. So, in this image, you can see zinc, aluminium, and magnesium has a increasing strength to act as a reducing agent or to act as to oxidize. So, these three metals can act as a sacrificial metal for iron. Okay. Another way can be connecting the steel reinforcement with another metal and supplying direct current between the two electrodes such that my steel is behaving as a cathode. So suppose I have a steel reinforcement like this, I have another metal like this, and I'm connecting them with the help of a external supply such that my steel is negative terminal, my this is a positive terminal. So what will happen? My cathodic reaction will occur here, my anodic reaction will occur here. So my steel will act as a cathode and this metal will act as an anode. So here corrosion won't occur. So which and this technique is known as impressed current cathodic protection since we are using external current to protect the steel. And which metal we can use here? It can be anything but a conductor. Okay. It can be titanium mesh, carbon electrode, zinc rod, zinc mesh, zinc or aluminum alloy, anything which is a conductor. Okay. Because here the metal's own tendency to corrode won't matter. The external supply that we are providing, it is governing which will act as cathode and which will act as anode. Okay. So in this image, uh, we you can see both the repair techniques has been illustrated in a very simpler manner and compared also. So this is my steel, okay, steel rebar, this is my concrete medium, and this is my external anode. Okay, now I can connect both steel and cathode and anode in two ways, either directly, okay, in sacrificial anode I am connecting them directly, and in impressed current I am connecting them with the help of DC supply. Now what will happen? My steel will become a negative terminal, my anode material, external material will become a positive terminal. So what will happen? My chlorides and sulfate ions will move towards positive terminal and my alkali ions will move towards negative terminal. Now since here reduction is happening, so what will happen? Oxygen will here convert into OH minus, and since OH minus has been produced, passivation will happen since alkalinity is increasing. Okay, and instead of converting from Fe to Fe2 plus, what will happen? Here my reduction reaction will happen. So Fe2 plus won't be forming, but it will be reducing back only. So here my corrosion product won't form. Fe to Fe2 plus conversion won't happen. While at anode, my Fe to Fe2 plus formation may occur. My Cl minus may also oxidize, and my oxygen and hydrogen ion may also be produced. But importantly, here those oxidation reactions are not happening. Okay, So how impressed and sacrificial anode differ from each other and which one is better? So in impressed, we need to use external power supply. Okay. But in sacrificial anode, the natural potential difference is governing this power supply. So in this way, SCCP is better in this context. But in impressed current ICCP, we may require a fewer number of anodes since the power supply is governing the protection. While in SSCP, more number of anodes may be required because the anode's tendency to corrode is governing the protection. Here, current supply is adjustable, so we can adjust the current that we are supplying based on how much protection we need. But here, since it is a natural potential difference governing process, current supply is not adjustable and we can't control the process. While here it requires continuous monitoring, and here it doesn't require continuous monitoring. So based on the application need, the cost of application and the demand, one can choose between both ICCP and SCCP. Okay, so in these images also you can see how SCCP units has been installed here, here also, and here also small sol. So these are like sacrificial anode covered with a uh, cover material, and they are tied directly to the steel reinforcement. So these material have a higher tendency to corrode. So what will happen? My steel will become cathode and they will become anode, and the material inside this, the zinc, rod, aluminum or magnesium that is there inside this, it will corrode. Similarly, here different sacrificial anode blocks have been installed at different locations to protect my steel from undergoing further corrosion. And in here also you can see a bridge, and underwater area you can see a zinc plate was applied at the top of the column, which will act as a sacrificial magnet to protect the underlying steel. And in this images you can see ICCP metals are installed on the surface of the concrete, and they will be connected to the steel substrate and the power supply, and that will help us to control the corrosion. Okay. Apart from these techniques, one can also think about like removing the chloride from the concrete or re-alkalinizing the concrete, and this can be done again by using power supply. How? So, since chloride are negatively charged, so if we place a electrode at the top of the concrete and make it a positive terminal and make rebar as a negative terminal and supply current between them, so what will happen? My chloride will be forced to move out of concrete, and I can collect them at the surface of the concrete and remove them. This method is known as electrochemical chloride extraction method. Okay. And similarly, we can also realkalinize the concrete near the reinforcement in a similar manner by promoting the movement of sodium stalls still reinforcement, which can act as a negative terminal where oxygen reduction will happen, hydroxide ions will be formed, and it will promote the passivation and increase the concrete alkalinity. Okay, so and this is known as electrochemical realkalinization. The setup is the same. If you are clear with this slide, what is the both the technique and this diagram, everything will be clear to you. Okay. Apart from this, another way to control corrosion damage is by using corrosion inhibitors. So, as per technical definition, a corrosion inhibitor is a chemical which is added, which when added into concrete as a at a specific dosage can reduce the rate of the corrosion. How these chemicals reduce the rate of corrosion? Either by promoting passivation, which are known as passivators, or by forming a film over the reinforcement, which are known as film formers. So in this image, you can see a rebar was affected by chloride ions and it was corroding. Okay, and it was unprotected. After cleaning, we applied a corrosion inhibitor coating over it, and now the chloride ions are not able to interact with the steel. So this is also one way in which steels can be protected. Now, in the images based on the capacity of the inhibitor, they can be classified into two types. Either they can diffuse to the concrete or they can be directly applied to the steel. Okay, so if my inhibitor has the ability to diffuse to the concrete, I can use it as an admixture while concreting, and it will diffuse in the concrete till the steel and protect the film. Or we can apply them as a surface coating also, if it can diffuse, or if or when the chemicals can't diffuse to the concrete, we can directly apply to the rebars also once they are exposed. Okay, so in this image you can see any corrosion inhibitor was sprayed on the surface of concrete elements, but here you can see when the reinforcement was got exposed, I was painting the they were painting the rebars with the corrosion inhibitor for protecting it. Okay. Finally, the corrosion damage can also be delayed by using coated reinforcements. Now, this is not a repair technique, but this is more of a method which can be out prior to construction. So it's not like when we see cracking in concrete, we will remove the rebar completely and place coated rebar. No, we can use them from the start, and what they will do, they will form a physical barrier over the reinforcement, which will hinder its interaction with the external ions. Now, this is different from the barrier that was created by corrosion inhibitor, because that was a chemical barrier and this is a physical barrier. Okay. Now there are several types of coated rebars available in market. There is fusion bonded epoxy coated rebars that is commonly used. There is cement polymer epoxy coated rebar, cement polymer composite coated rebar that are new and coming up in market. There are stainless steel, which is not a coated reinforcement, a form of special reinforcement. And there is galvanized rebar also, which is again a coated reinforcement where the steel substrate is there and over steel zinc galvanization is done, such that my zinc will act as a sacrificial matter and it will protect my steel inside. Okay, so in this way also corrosion can be controlled. I hope everyone are clear with the discussion of corrosion, how corrosion is monitored. Any doubts in this?
Actually, sir, this is a good material suggestion what you have given for this corrosion inhibitors.
Hmm.
But in the old age building, what is happening? This is another part I am saying. In the old age building, actually, what is happening? Even though we use waterproof treatments, still then there is a leakage. That is why, because we are treating the roof surface only. Normally water is penetrating through the parapet or outside of the wall, and it is going through the porous concrete.
Hmm.
And actually what is happening, because this conduit pipe is not having proper adhesiveness with the concrete, through that porous media, it
Hmm.
is going and getting stagnated in the ceiling fan areas, and through that leakage is coming. So
Hmm.
this type of leakage issues, how to address? What type of chemical component is available in the market?
There are
Kindly
different
suggest this
kind
one.
of like corrosion inhibitors that you can look out. There are amine based inhibitors, alcoamines based inhibitor, there are nitride based inhibitor. A lot of chemicals are available in the market. If you will like try to do some research, try to read some papers and everything, you will find a lot of solution. And the problem that you
Okay.
told na, we apply some waterproofing sealing, still there is leakage problem from the side. Mainly,
Yes.
the problem of corrosion will occur on the outer surfaces. Okay, my
Yes.
columns or the members that are inside the structure, they are not like in direct contact with the environment. So you need to make sure that your outer columns or the surface are properly waterproofed. And even after waterproofing, before waterproofing, you can use some migratory inhibitor which can stop the increasing rate of corrosion. It won't regain the property of steel again, but it can stop the steel from corroding further for some time. And then you can use
Okay.
some coating, which will be a double layer of protection for you. Okay.
Okay.
Or if you see still it is not working, then you can go for such cathodic protection systems also, which you can install on the surface also, and you can protect the structure if it is that much critical. But corrosion repair is like very deep and very complex. So if you have a
Okay.
building or you are managing a project, a bigger project that you need a proper expert solution on that, then you need to contact some proper experts. They will tell you what all possibilities you have and what will be the cost and which is one is the most suitable. Since
Okay.
I work in the area of corrosion in my PhD, I am able to illustrate this far. And this discussion that I have told you right now regarding corrosion damage, how to think, and how to move forward, it can be very useful to you.
Okay, okay.
These slides will be very useful to you in terms of deciding what to do.
No, actual sir, for this when protection of the plaster surface, there are chemicals available like the Glycosyl, this crystalline chemicals are available. But actually, what happening over that again we have to make this polymer plaster, which is actually very cost
So
effect.
for such things, then
That
you
is,
need to like have a proper guidance based on your
mm,
structure, location, extent of damage, and extent of repair you want. A lot of factors is important when you are choosing a repair material. So
yes.
you need to go forward with that. Okay.
Actually, for a residential house, it is not issue. It is a issue when suppose a public area is there. So
Hmm.
many structures are there
Hmm.
in government buildings also. Actually, we should not go for expensive chemicals and all. We
Hmm.
need some economical solutions. Actually, whether any company is dealing with such type of products, then one session on that product demo and all.
Hmm.
Suppose you will make, it will be beneficial for everybody.
I will try to look into that, but if you have some specific problems, you can always look for those products. Okay. Since this course is very vast and this is a very small portion of the discussion, I can't like give a whole more time on the specific topic only.
Okay, sir.
Okay.
Okay,
I
thank you.
will just quickly conclude the session since we are over time. So in this session, we first had an overview of petrographic investigation and load testing. Then we talked about repair and retrofitting, how to decide which one is needed. Then we discussed how concrete surface is prepared prior to repair using shoring and scaffolding. Then we discussed in detail different repair techniques, starting with repair materials, then their application, either as a mortar or through grouting. We later discussed various ways of grouting applications, also drilling and plowing, pre-placed aggregate, routing, sealing and stitching and stapling. And we discussed shotcreting also, dry shotcreting and wet shotcreting, and ferrocementing also. Finally, we discussed different ways to repair or control corrosion damage on reinforcement, in which we talked about cathodic protection technique, SSCP and ICCP, electrochemical chloride extraction and realkalization, use of chemical corrosion inhibitors, and use of coated reinforcements. Okay, so this was all for today's discussion. Uh, any doubts? If anyone have any small doubts, which he or she can ask quickly.